Hi and welcome back. Today I'm going to be laying out my approach for how I would build an anvil if for whatever reason I had to start all over today. So if you're frustrated with trying to find a decent anvil at a decent price, or you think that building an anvil is just not something that you're going to be able to do, well, hopefully this video will help you out. So I started out pretty much the same way everybody does. At first you just find some kind of block of metal to hammer on, and then as you work through that process, you start building up, an anvil collection. And what I have here are my first three anvils. The one on top is basically the anvil that I grew up with. It was just a short section of railroad rail, and it was always on my dad's workbench. And we used it for straightening nails and that kind of a thing. I used it as my first anvil. I mounted it to a block, and actually I was quite happy with it for quite a while. The second anvil in the stack is just a basic track anvil, and I think this is probably the most familiar anvil out there. Everybody at some point in time winds up with one of these, and this is mine. It was just cut out with a torch and ground to shape, but at least it looked like an anvil, so I was able to convince myself that I was really getting somewhere. And part of me felt really good standing behind this thing. And of course at the bottom of the stack is my first real anvil. It took me a couple of years to find this anvil, so I was really happy when I did. And it is obviously a big improvement over the other anvils that I have. This one weighs about 85 pounds, and it has a big sturdy base which makes it extremely stable, so you can get a lot of work done on this anvil despite its weight. And this was the anvil that I used for well over 20 years. It produced a lot of work, and I was very happy with it. However, I did stop using this anvil for a short time when I managed to find a small London pattern anvil that I could afford, and that was, the big prize. It was the epitome of anvils as far as I was concerned at that time, and the narrow waist and the graceful lines made it a really good looking anvil. It was also a little bit heavier than the anvil that I was using at the time, so I really felt that this was a step up. But when I started using this anvil, I realized that it was really a badly designed anvil for forging. The problem with that design of an anvil is the narrow waist. If you keep the same proportions and just start shrinking everything down, it gets to a point where that narrow waist just won't support any amount of work. It turns into a big tuning fork, and you can't keep it from vibrating and moving around no matter how much you clamp it down to a heavy base. This anvil does work fine on a much larger scale, but the one that I had just didn't perform as well as my original anvil, so I switched back. So this experience taught me a lot about what I wanted to have in my next anvil. And several years later I found the anvil that I'm currently using. It's the same shape as this first anvil, but it weighs 230 pounds. I really like the extra length and width of the working surface, but I really thought that the extra weight would really be a big advantage, but turns out that it really wasn't. Because I had my first anvil clamped down to a heavy base, the difference in performance was really pretty minimal. And I think the main reason for that is the proportions of the base. The footprint on my large anvil isn't a heck of a lot larger than the footprint on this small anvil. So the difference in those sizes seems to compensate for the weight difference. So the first thing you need to consider when you're building your own anvil is that the anvil and the anvil base are one unit. You have to think about the whole package as something that works together. The base isn't just something that elevates an anvil up to a working height. It's the key element that allows you to get the best performance out of your anvil. This is basically how my track anvil was set up. The base is an old machine stand that I had kicking around. I don't know what it was originally used for, but I used it for the base of my anvil for the first year or so that I was working. I have the standard bracket that I use to set up all my different workstations, mounted to the side of this machine stand, but basically this is how it looked. The track anvil was bolted very securely down to this machine base, and the wide base of the machine stand made it a very, very stable platform. So even though this anvil is very light, When you bolt it to a heavy base, it starts to work like a much heavier anvil. So when you're setting up your first anvil, don't underestimate the importance of attaching that anvil to a heavy base, and then if possible attaching that base directly to an even larger base like a metal plate or the floor. If the anvil moves when you're hammering, it doesn't matter how heavy the base is, it's not doing you any good. Here's an example of how I'm using this stand today. I have a vise set up in that bracket. It's just a filing vise, and I do some light chiseling, so it doesn't matter that it's overhanging the edge this far. I have the base set up on a rolling platform, and the height of the vise is just perfect for when I'm sitting. So if I need to do something for a long period of time, this is quite often the vise that I'll roll out and use. And I'm showing you this because this is quite often something that gets overlooked as an approach that can be used for an anvil, because having a vise this low actually serves very well as a hardy hole substitute. In fact, this is how I had my shop set up for quite a few years. I had a series of low vices set up on a heavy metal plate. Each vise was supported on, an I-beam with its, own little table, and all of that was welded to a metal plate. So the whole system probably weighed well over 300 pounds. So my main anvil was just used for forging. I would set up all my stake anvils or jigs and fixtures that I needed in these low vices, and that's what I forged on. The vise that you see here is just an inexpensive vise, so I didn't do any heavy hammering on that, but I did have one massive vise that weighed well over 100 pounds. It was an all-steel machinist vise, had I think 8-inch wide jaws. I don't remember. It's buried in the shop somewhere. I don't want to lift it anymore until I'm sure that it's gonna go in one place and stay there. But anytime I needed to set up an anvil block or a stake anvil that was going to be really used, for a lot of heavy hammering, I would set it up in this vise, and it worked just like an anvil. Again, it had that heavy base. It was a heavy vise, and once you locked something into those jaws, it did not move. So if all you can find is one of these big machinist vices, don't pass it up, because mount that to a heavy base, to a heavy plate. You have a system that you can use to forge just about anything. You could put just a sledgehammer head in the jaws of this vise, and you will have a usable anvil. And again, anvils don't have to look like anvils, they just have to do the job that an anvil does. The idea that anvils don't have to look like anvils becomes pretty obvious when you look back at the history of anvils, because for probably well over 1,000 years, anvils were really just square blocks of wrought iron. These anvils probably represented the largest blocks of wrought iron that could have been made and forged at that time, and would have come from specialized shops that had the manpower to handle that kind of work. The anvil would have been used for all the basic shaping of the metal, and any specialized work would have been done on stake anvils. The stake anvils could be made with much lighter materials, and they were probably made by the smith himself to suit whatever kind of work he was doing. And over the years, of course, there were quick advancements to the technology, and they were able to work with larger pieces of wrought iron and build more complex structures. So you started finding some of the elements that were usually on stake anvils appearing on the main anvil. So even though this anvil starts to resemble the anvils that we have today, this is still a forging anvil designed to be used by smiths that are going to be moving a lot of metal. The body of this anvil is still a big solid block. The horn is short and stubby, and the heel is very blocky, and both the horn and the heel are buttressed back into the main body of the anvil, so they are extremely stable and good working platforms. So if you were a farrier, for example, you probably made the shoes on the main anvil, but you would still need to shape and fit the shoes on something like a stake anvil, just because you needed something that could conform to the tightly curved shapes that you're working with. So the majority of the anvils that we're familiar with today are the result of the Industrial Revolution and the needs of mass production to be able to find a product that can suit the greatest number of customers. This anvil also represents the changing role of the blacksmith in our society. As we all know, the Industrial Revolution took away 95% of the blacksmith's role in the manufacturing industry and also tripled the amount of horses that were needed to move all of the goods produced by the Industrial Revolution. So the farrier became the prominent blacksmith in any community. So here we start seeing the development of what's commonly referred to as the London pattern anvil. The main body of the anvil is starting to shrink in size, and the horn and the heel are becoming the predominant elements of the anvil. So this anvil is a specialized tool that's designed for a smith who spends most of his time shoeing horses and is only occasionally required to do some forging. Here are the two anvils side by side, and if these two anvils were the same weight, you can obviously see how the one on the left would really outperform the one on the right. So anvils have always been big, heavy pieces of equipment, so it's pretty natural to assume that anvils need to be big, heavy pieces of equipment, but modern engineering has taught us that that isn't the case at all. The fact is that this anvil would work equally well if it was half the weight and hollow on the inside. The exterior faces of the anvil are doing all the work, and the center part is really just adding weight to the anvil, and now we know that we can move that weight somewhere else and it'll perform just as well. They've always been solid because that was always the easiest way to make them. So in my opinion, the modern approach of producing an anvil is not to try to weld up a solid 300-pound block of metal, but rather to use the structural steel that's available anywhere and build up a framework that'll support the hammering and transfer the load from the anvil face to the anvil base. Now this might sound like I'm starting to contradict myself because I'm suggesting that a relatively light anvil is going to work just as well as a heavier anvil, but that's not actually what I'm saying. I'm saying you can move the mass out of the anvil and make that structure easier to build as long as you compensate for it by moving that mass into the base and attaching the anvil and that base so they work as a unit. So the anvil is basically the work surface. It has to be a framework that can support the amount of hammering and heat that it's going to be subjected to, and more importantly, it has to be a structure that will transfer all those forces down to a sturdy base. The base is, in this sense, really the key to the whole process because it provides the stability and the weight that we need in an anvil. If you have those two elements, and again, if they're firmly connected, you have a good anvil. I can illustrate this point by showing you a couple of clips from another video that I'm working on. I recently built some anvils for a program that I'm setting up in our local makerspace, and these anvils needed to be light and portable, so I made a pretty light anvil and I put it on a light base because we were going to be moving them around and I didn't really feel like lifting a heavy anvil. The anvils turned out really well and they're solid, but the base was far too light. So what I had to do was I added some panels to the side and I filled the base with cement. And it was pretty amazing what, basically one bag of cement did to the whole structure of this anvil. Now the whole unit weighs over 100 pounds and they're really good, usable little anvils. They're very sturdy, there's absolutely no bounce, and they don't walk away on you anymore. The tiny bit of movement that you're seeing here is because the outriggers for the base are working loose slightly. I've since added a gusset plate to the end of the anvils and that corrected the problem. So now these little anvils are rock solid. So again, if I had to start over based on what I know now, my first anvil would be totally welded out of structural steel. I would go to a machine shop or a welding shop and find a drop that was long enough to make the total anvil from anvil height right down to base, taking into account, of course, the thickness of the plates that I'm going to be using on the top and bottom. That column I would weld to a square metal plate, again, as thick as I could find, but not so thick that it becomes a tripping hazard. And if I was working on a cement floor, I would mount that whole structure to the floor. Tying everything in, again, is crucial. I would fill the column with cement and then I would weld my top plate. Now the top plate is one area where you really don't want to skimp a lot. It needs to bridge the gap between the two sides of this square column. So depending on the size of that column, you're going to need a fairly thick plate to resist all of the hammering on that surface. From that point, it's pretty much a blank slate, and you can add on whatever you like. Now, if you don't have a welder or you don't know anybody that can help you out with this and you need to farm this out, you can save a lot of money by doing all the prep work yourself. You can buy the column, get the top plate, cut it to size, build a horn or whatever else you want to do. Get it all ready, take it to a welder and say, just put this together for me. At that point, you can bring it home and use some heavy angle iron to fit the column to the base plate. You're going to need to bolt this together, obviously, because you don't have a welder. So get all that ready, bolt the angles to the column, and then fill the whole thing with cement. And then at that point, it's just a matter of flipping the whole thing over and drilling the remaining holes that you need to attach the column to the base plate. Now, if you see a length of railroad rail and it's long enough, don't pass it up, because they still do make good anvils. You just need to stand them on end and use the whole length of the anvil to give you the mass that you need. If you do a search for makeshift anvils or shop-built anvils or something like that, you'll see a lot of people have, really come up with some pretty innovative ideas on how to put together railroad rails into really good anvils. This beam has a pretty complicated cross section, so if you can't weld it to a heavy metal plate, the best solution is to cast it into a block of concrete. And of course the same holds true for, a heavy section of square bar or an extremely heavy section of flat bar. Stand them up on end and use the whole weight of that piece as an anvil. So I hope this video helps you out and gives you some ideas of, thinking about anvils in a different way. And again, the column anvil is really how I would start if I had to do it all over again. The important thing is to get started and do some forging. The problem with buying an anvil too early is that you don't really know what you want until you've used something for a few years and you develop a way of working, and the anvil has to fit into that. There is no standard anvil that's going to work for you. The shape that I like isn't going to be the shape that somebody else likes, and so you're going to have all these different opinions, which is fine. It's great that they're out there, but you have to figure out what works for you, and that takes time, and that takes a lot of hammering and a lot of work. So the best thing to do is to use basically disposable anvils that you can work with, modify, alter, try out ideas, cut them off, try something else, whatever, until you come to a point where you say to yourself, okay, that's the anvil that I need. I'm going to wait till I can afford it or I can find it somewhere cheap, but that's what I'm going for, and I'm going to use this anvil until I get there. Hi, I'm Dennis, and thanks for watching. If you have any questions, you can contact me directly by emailing the address I have displayed here. If you want to find out more about me and what I'm working on right now, go to my website, dfntheshop.com.